Hello and welcome to Mr. Morton Science Videos. I'm Mr. Morton and this week we are looking at GCSE past paper questions. As always, the paper we are looking at is linked to in the description below, so if you want to have a go yourself, just click on the link and have a go. Today we're looking at AQA Chemistry Unit 1, the higher tier paper from June 2013. And this is question 2, and this question is all about metals. Metals are extracted from their ores. Many copper ores contain only 2% of copper compounds. Copper is now extracted from ores containing a low percentage of copper compounds, suggests two reasons why. The important part to this question is that we're only looking at ores that contain 2%, that's relatively low, but we're now using them. So the question is asking us why we're now using these compounds. There's two reasons that you can use. One is that we have used up all our high grade ores and we still need copper for other things, so we don't have anything better than 2%. And the other reason is that the demand is still increasing. So if you put both of those in, you'll get those marks. So I'll put those in now. Another way of saying high demand is that it's expensive. Either of these will get you the mark. Part B. Chalcocite, an ore of copper, contains copper sulfide. The flow diagram shows how copper metal is extracted from chalcocite. Okay, it's quite a complicated diagram, but it's not meant to scare you off. We've got chalcocite, which is our 2% ore, going into a crusher. Okay, so that's been crushed up into smaller lumps. This is then passed through a bioleacher. This is where we use bacteria to concentrate the ores. And you're left with a lot of waste. This is where you're going to lose most of that 98%. You then got this concentrated solution of bacteria and ore going through an electrolysis cell. Okay, just like the cells that you've seen for aluminium, where you've got your electrodes, positive and negative. And what's left out, or what is drained out, would be your pure copper. That's here. You've then got some other parts of the ore, the really powdered stuff, being put through a separator. Again, that's part of your 98% that you're losing there, your waste rock, and you end up with a compound called copper sulfide, CuS. You're then passing that through a furnace. That's going to be very hot. 1200 degrees C is going to use a lot of energy. Okay, and we're reacting oxygen with it. Now that oxygen is going to react with something in this furnace to leave copper left over. It'll be impure, there'll be some impurities in it, but it will be mostly copper. So that oxygen is obviously going to react with this sulfur here. This is the next part of the question. Suggests one reason why it is difficult to dispose, that means get rid of the waste rock. Now, one of the main reasons why it's difficult to dispose of it is just there's so much of it. From our previous diagram, we could see it was 98% of it would be waste. So it's just one reason why it's difficult to dispose of the waste rock. There is lots of waste rock, 98%. Okay, that's going to be a huge amount. Second part of the question. The reaction in the furnace could cause environmental pollution. Explain how. Now this goes back to the diagram that we had earlier. Okay, where is this environmental pollution coming from? It's going to be coming from this furnace here. You've got oxygen going in, reacting with the copper sulfide and producing a waste gas. Okay, and the waste gas that you're going to make is SO2 because it's sulfur and oxygen reacting together. The sulfur from the sulfide, the oxygen from the oxygen, they're adding SO2, which is sulfur dioxide. Now, sulfur dioxide causes environmental pollution, and the pollution it causes is acid rain, which is one of our types of environmental pollution that we have to learn about in C1. Okay, so we're going to put oxygen reacts with sulfur to make sulfur dioxide. And then sulfur dioxide causes acid rain. And that will be each worth a mark. One for saying sulfur dioxide and one for saying acid rain. The extraction of pure copper is expensive. Give one reason why. This also goes back to this diagram here. Why is the extraction of pure copper expensive? And it's to do with the amount of energy it takes to heat this furnace. 1200 degrees C is a lot, and then you've got to do electrolysis afterwards. So there's two ways that you can write this down. The first way is to write down that it uses a lot of energy. And that's the energy that's being used for the furnace and for the electrolysis. Because the electrolysis also has to happen at a high temperature. The other way of writing this down is that there are many stages in the process. On other papers, they can give you this many stages question in lots of different ways. So if there's lots of things in the flowchart, the chances are that makes it expensive. Part 4. Pure copper is produced by electrolysis of copper sulfate solution. Electrolysis. Which electrode do the copper ions, not atoms, ions, move towards? Give a reason for your answer. Now, copper is a metal, and all metals lose electrons. Now, when you take a neutral atom and make it lose electrons, it becomes positive. So we know that copper forms positive ions. So copper forms positive ions, and those are actually Cu2+. And then positive ions are going to be attracted to the negative electrode because they're attracted to the opposite electrode. So copper ions are attracted to the negative electrode. And that will get you 2 marks, one for saying they're positive ions, and one for saying they're attracted to the negative electrode. Last part of the question then. Large areas of land are contaminated with copper compounds. Phytomining can be used to remove these copper compounds from the land. What is used in phytomining? Now, phyto is when we're using plants. So phytomining is using plants to remove copper compounds from the land. This is another one of those modern technologies that allows us to extract copper from low-grade ores. And so by using phytomining, we're actually growing plants. And what happens is the plants themselves absorb the copper minerals from the ore, and we then take the plants, we burn them, and we extract the remaining copper from the ash, which is a much higher concentration than it would have been in the ore to begin with. Okay, hopefully you've enjoyed this video. I'm going to go on to do question 3 next. I'll put the link below. Thank you for watching.